All right, this is 8/8 homework in the textbook. We're on page 508. We're just doing questions 6 through 12, looking at the distance formula. So distance equals the square root of all of this. So we will have to evaluate everything underneath the square root first. The last thing we're going to do is actually take the square root. We have x2 minus x1. That whole quantity gets squared. And we have y2 minus y1. That whole quantity gets squared. We're going to add those two numbers together and then take the square root. Now, this x2 and x1, we've worked with this before with slope. We've talked about it doesn't matter which point you call your x1 and your x2, your y1 and your y2, but you have to be consistent just like we were with slope. Whatever point you designate as your x1, then that matching corresponding y value has to be the y1. And same with x2 and y2. So those have to match, but it doesn't matter when you start off which one you put in which place. All right, as we look at number 6, the first one we got to do, we're looking at a triangle, and we have to find the length of AB. When these are on a graph, if they are straight horizontal or vertical, going with the grid, you can just count boxes, and we're going to take a look at that. But if it's diagonal, and that's the lines that we're actually looking for here, the length of AB is the diagonal line, you can't just count boxes. It doesn't work like that. So we're going to use two different things. We can use the Pythagorean Theorem, which we've been using for a couple sections here. And then we're also going to use this new distance formula. So for number 6, I'm going to do it both ways to show you how they correspond together. And then number 7, we'll choose the better of the two. Once we get down here, we're just given 2 points. And so the best practice there is just going to be plug it into the distance formula and go from there. So starting on number 6, let's say I want to use Pythagorean Theorem. Let's start there. This would be my 90-degree angle. And so diagonal from that is my C. So AB, our missing piece. Okay, what we're looking for is our C. So that's what's got to go here. So I'm going to call that X for now, just to change the letter. We already have these two values. They're given to us. We don't have to actually do any math, just count boxes. So this one right here is 1, 2, 3. It's going from -1 to 2. That's 3 units. So I'm going to plug that one in for A. Remember, it doesn't matter, A or B. And from here, we're going from 1 to 7. That's 6 units. 1, 2, 3, 4, 5, 6. So that side is 6. So I know that this side is 3 and this side is 6. I can use Pythagorean Theorem to go ahead and find my hypotenuse. So 3 squared is 9. And this is 36. Put them together, that's 45. Now that's x squared, not x, so we have to take the square root of both sides, which gives us x alone. And square root of 45, not a nice number. Okay, so we can leave it just like that. If you want to give the approximate answer, plug it in your calculator. I don't believe the directions stated. They didn't give you any way to round, so you can round this however you want. 6.708 approximately. Okay, and that's it. Now, that was pretty easy. What about the distance formula? So what if we run this with the distance formula? So I'm going to go ahead and use these 2 points. I'm going to write them down here. I have 7, 2, and I have 1, -1. Those are the 2 points that I'm trying to measure the distance between. So I'm going to call this 1 and this 2, but it doesn't matter, really, as long as you go the same direction. So when I do my x's here, it's going to be the 7 and the 1. I'm going to do 7 minus 1. That just means since I went this direction with my x's, I have to go this direction with my y's. If you went the other way and you did 1 minus 7, that's fine. You're not going to get it wrong as long as you do the same thing with the y's. And then you go this direction, -1 minus 2. So you just have to be consistent, much like we talked about with slope. So my distance is going to equal x minus x. So 7 minus 1, x minus x, and then my y minus y, 2 minus -1. Okay, real quick, 7 minus 1, that's 6. and that's going to be squared. This goes plus plus, and this is 3 squared. You should start to see how this mirrors this over here. 6 squared is going to be 36, and 9. When I put those together, it's 45. And so distance equals the square root of 45. We're right here, and again, you can go ahead and get that answer either way. So I want you to see the correlation between the two, and then be able to choose in the future which one you think works best. So as we move to number 7, I'm going to go ahead and use Pythagorean Theorem on this one because I think it's easier. So a squared plus b squared equals c squared. Again, we're looking for the hypotenuse. That's what we're looking for. So I'm going to call that x. This piece right here is 2. And from negative 2 to 4, that's 6. 1, 2, 3, 4. Oh, I'm sorry. It doesn't go to 4. I saw the 4 here. It goes to 3. That's why I count and double check yourself. It's from negative 2 to 3, which is 5 spots. 1, 2, 3, 4, 5. So 5 squared. So 2 squared is 4, and 5 squared is 25. Together, that's 29. To get rid of the x squared to make it x, I have to square root it, and I have to do it to both sides. Square root of 29, final answer. If you want to find the approximate, plug it in your calculator, 5.385. And if you're in the distance formula, it would work similarly, but I think for these, it's your choice to choose which way you want to do it. And I think Pythagorean Theorem would be quicker here, just so I don't have to deal with picking points and plugging in, but you may feel that that one's easier. So whichever way works for you, they're both going to get you the right answer. All right, I've got 4, 9, and 8, 6. I'm going to plug this right into my distance formula, subtracting my x's. So if I look, you might not want to do 4 minus 8, right? You might say, well, I want to do 8 minus 4. But if I go that direction, then I'm going to have to do 6 minus 9. So either way, you're going to be getting a negative number. But what happens when we get a negative number inside these parentheses, we end up squaring it. And any negative number squared, like negative 3 times negative 3, is going to get you a positive answer. So even if you get negatives, you're still going to end up with positives later. So it's not a big deal. So I'm just going to go from left to right with mine. So I'm going to do 4 minus 8 for my x's. And I'm going to do 9 minus 6 for my y's. So 4 minus 8 is negative 4. But again, it really, in this case, isn't going to matter because we're going to square it and it's going to become positive 16. 9 minus 6 is 3. Squared is 9. Put those together, that's 25. The biggest mistake students make, and maybe it's because they're doing what I do and kind of shorthand it, is they forget that this is the square root of 25. So they'll just leave 25 as their answer. We have to square root it. Now, square root of 25 is a nice number, so we're going to go ahead and fully solve this. Remember, square root means the number times itself to get that number. So 5 times 5 is 25. The square root of 25 is 5. We've got a nice answer. Once you get the hang of these, they are not too bad. So 15, 2, 20, negative 10. Subtract my x's, that's 15 minus 20. Subtract my y's, that's 2 minus negative 10. So I get negative 5 squared. This goes plus plus. That's 12 squared. So negative 5 times negative 5 is 25. 12 squared is 144. I'm going to put those together. So 144 plus 25 is 169. And I got to remember to carry my square root all the way down. And you may not know it, but the square root of 169 is a nice whole number. 13. 13 times 13 is 169. All right, number 10. 5, negative 1. 11, 2.2. So I like to just go from left to right. 5 minus 11 plus my y's, negative 1 minus 2.2. So 5 minus 11 is negative 6, which squared is 36. And now negative 1 minus 2.2 is going to be negative 3.2. And we need to square that. Now, a negative times a negative is going to be positive, so we need to make sure we don't, by an accident, put a negative here. So it's negative 3.2 squared, which is 10.24. This whole thing, remember, is still under our square root. So we're going to go ahead and put that together. That's going to give us 46.24. And we're going to need to take the square root of that. And that comes out to a nice even decimal of 6.8. So we're not going to round that. We're just going to go ahead and leave that. So distance equals 6.8. All right, 11. Dealing with some negatives, which sometimes can mess you up, so we got to be careful. So I'm going to subtract my x's. That's negative 6 minus negative 2 plus negative 7 minus 0. So this goes plus plus. That's negative 4. And that's 16. Negative 7 minus 0 is negative 7 squared. 49. Put that together. That's 65. Carry the square root all the way down. Final answer is the square root of 65. You could get the approximate answer, 8.062. But we're good with this answer right here, square root of 65. You'd want to check and see if you could simplify it. If you want to leave it as a square root, you always can. You can get the decimal answer, and obviously the directions sometimes will be specific and say get the rounded answer or give me the simplified answer. This is the simplified answer. You'd have to double check and make sure that you can't simplify like with things like 4, 9, 16, 25, 36. Make sure that they can't go into it and you can split it and simplify like we did in 8.7. But none of those are going to go in. So there's nothing we can do there. Square root of 65 would be the simplified radical answer. And 8.062 is our approximate rounded answer. So we're going to go to number 12 and finish this off. We got negative 1, 2, and negative 3, 4. So x is negative 1 minus negative 3 plus my y values, 2 minus 4 squared. So this goes plus plus. Negative 1 plus 3 is 2. Squared is 4. Negative 2 minus, positive 2 minus 4 is negative 2 squared is 4. So together that's 8. Now again, you can't forget that this is going to look like this. Square root, you got to carry that down. Don't forget, the answer is not 8. It's the square root of 8. Approximate answer of that is 2.828 if you plug it in the calculator. But we can simplify this. So if it said simplest radical form, this would not be full credit right here because we can split this up into square root of 4 times the square root of 2, right? Because 4 times 2 is 8. And the reason we would split that is because square root of 4 is a nice number. It's 2. Square root of 2, not a nice number, so we leave it like that. So these are all possible answers, but this is simplified. Let's take a look. If we have the square root of 8, here's our decimal. And if we have 2 times the square root of 2, there's our decimal. So all of these are equivalent. Now real quick, I just want to show you if you did this backwards, you're still going to get the same answer. So I want to work this backwards one time just so you can see it. So if instead of going from left to right, I went the other direction, because some people always get hung up on, well, which one's x1 and which one's x2, and it doesn't matter. So now I'm going to go this direction because I've been going the other way. So it would be -3 minus -1. Then it would be 4 minus 2. So this goes plus plus. -3 plus 1 is -2. Squared is 4. 4 minus 2 is 2. Squared is 4. You still end up with the 8. And then, of course, you'd carry that square root down and keep going from there. All right, so it doesn't matter which way you go. You just have to be consistent. Whatever you choose to do with the x's in terms of direction, make sure you do the same thing with the y's.